FGM-3 prototype update number 3. So today I'm going through the sensitivity settings, making sure that all the logic levels are correct, and they are. And I'm testing overnight. I connected one of the FGM mates to a very old 10-foot Ethernet cable, just a ordinary CAT5 cable. Do not use crossover cables with this design, as some of you know. One end of a crossover cable has two of the lines switched, and that could be a power, a ground, or who knows what, and it'll probably result in this either not working, or it could actually damage your shield. So just a word of caution. So here's my speak sensor connected to its mate. 10 foot of CAT5 going just to a jack I've got soldered up here. So this is sending the supply down pin 1 and ground on pins 2 and 3, and then that 12 volt, well, 9 to 12 volt gets regulated to 5 volt right at the sensor. The sensor sends back a 5 volt OK logic signal saying we're connected, which is that blue LED that's coming back from pin 4 on the Ethernet, and then pin 8 sends back your frequency, and you can see the frequency in software. So as you can see, my plots are all over the place, and it's due to the sensitivity of the sensor, and I'm in a very noisy environment. For my worst case scenario test, I've got two brand new CAT5 cables. The right one's 100 foot, the left one's 200 feet. I'm going to be doing my signal degradation testing with 200 feet. So in a while I will connect the mate to 200 feet of CAT5 and get the sensor far away from these electronics to get a more stable output, and this will allow me to isolate the sensor for proper testing and test it over an extreme length of cable. Why would you need 200 feet? If you're in an urban, rural community, say you live on half an acre or a third acre in a city environment, then you'd probably want to get this far away from moving vehicles, power lines, things of that nature, your furnace, your central heat and air, as they are very sensitive. So that's why I call it the worst case scenario. So if the signal comes back, if there's no voltage drops, and we get a good square wave coming back on 200 foot, I'll be very pleased. Although for most applications, I think 50 feet will be fine. Maximum perhaps 100 feet. We'll be shipping the kits with 50 feet. And we may offer 100 foot as an option, along with the Bluetooth radio, which the Bluetooth still needs to be tested. It should work, software, firmware, and hardware wise, but that'll be one of my next tests after isolating the sensor with 200 feet of CAT5. and I'll probably also do a test with 100 feet. But my main concern is very long cable lengths and signal degradation, which the onboard Schmidt trigger should reshape if there's any signal degradation. So the next video will be set up with the FGM8 connected to the breadboard with 200 feet of ordinary Ethernet CAT5 cable.